If your AI agent takes action, you need an audit trail, not just a chat history, a real operational record of what happened, why it happened, who approved it, and what changed. Here is the uncomfortable question for any production AI agent. Can you prove what happened? Not guess. Not summarize from memory. Not ask someone to scroll through a messy conversation. Prove it. If an agent updated a ticket, who asked it to do that? What data did it use? What tool did it call? What policy did it check? Was approval required? Who approved it? Did the human edit the recommendation? Did the agent skip a required step? Did a tool fail? Was sensitive data redacted? What version of the agent was running? If you cannot answer those questions, you do not have an operational agent. You have an activity stream with no evidence trail. And when something goes wrong, that is painful, because without audit logs, you cannot confidently debug the incident, explain the behavior, improve the workflow, or decide whether the agent should keep running. So in this video, I want to show you what AI agent audit logs should actually capture. A common mistake is treating a conversation transcript as the audit log. That is not enough. A chat transcript can be useful context, but it is usually incomplete. It may not include tool inputs. It may not include tool outputs. It may not show approval state. It may not show policy checks. It may not show data source versions. It may include sensitive information that should not be stored forever, and it is hard to query. Audit logs should be structured. They should capture events. Agent received request. Agent selected workflow. Agent retrieved data. Agent proposed action. Policy check passed. Approval requested. Human approved. Executed. External write completed. Sensitive field redacted. That kind of event history is much easier to search, filter, report, and investigate. The transcript can be attached when appropriate, but the audit trail should not depend on the transcript alone. The foundation is basic event identity. Every important agent event should answer 5 questions. Who triggered it? What happened? When did it happen? Where did it happen? And why did the agent decide that action was relevant? For who captured the user role, system account, or automation trigger? For what captured the event type? Request received, tool called, approval requested, action completed. Action block. For when use timestamps that are precise enough to reconstruct order. For where, capture the workflow, environment, system, ticket channel, or project scope. For why, capture the agent's reason in a short structured field, not a giant essay. Something like scanner finding match TRIAGE rule, asset is production, remediation deadline is overdue. This gives you the core timeline. Without this foundation, every investigation becomes detective work. Tool calls are where AI agents become operational. So tool activity needs careful logging. For every important tool call, capture the tool name, the action, the target system, the permission level, the request status, the result status, the error if one happened, and the object that changed. But be careful. Tool logs can contain secrets and sensitive data. You do not always need to store full raw tool input and output. Often you want a safe summary. A tool called vulnerability scanner lookup, target finding ID redacted, result evidence available, sensitive fields redacted yes, status success. For debugging, you may keep short-lived secure traces with stronger access controls. But the normal audit log should not become a warehouse of raw credentials, private messages, customer data, or internal vulnerability details. Log the event. Log enough to investigate. Do not store more sensitive data than the audit task requires. Human approval is only useful if you can prove it happened. So approval events deserve their own audit records. Capture when approval was requested, who approved it, what they approved, what exact action was released, whether they edited the agent's draft, whether they rejected it, whether they overrode the agent, and whether the approval was required by policy or optional. This matters because approvals are a feedback signal. If humans approve 95% of recommendations without edits, that tells you one thing. If they edit half of them, that tells you something else. If they keep rejecting a specific category, your agent or policy probably needs work. Approval logs help you improve control and improve the system. They are not just compliance paperwork. They are operating signals. A good agent does not just do things. it checks boundaries. So your audit trail should include policy events, policy check passed, policy check failed, action blocked, approval required, sensitive field removed, user not authorized, tool not allowed in this environment, external send blocked, rollback triggered. These events are easy to ignore because nothing dramatic happened, but they are extremely valuable. A blocked action tells you the safety system is working. A repeated blocked action tells you the workflow may be unclear. A missing block tells you there may be a control gap. In cybersecurity workflows, policy logs matter a lot. If an agent tries to change severity, close a finding, or post externally, you want to know whether the action was allowed, blocked, or approval gated. The absence of action is still an event. Log it. Agent behavior changes over time. That means your audit log needs version context. For important actions, capture the agent version, the prompt version, the model, the tool permission version, the policy version, the retrieval configuration, the data sources used, and the environment. This does not mean storing the entire prompt in every log record. That would be noisy and risky. Instead, store stable IDs and references. Agent version 2.1, prompt version 7, policy bundle 3, retrieval index updated May 24th. Scanner source version current at time of request. Now, if behavior changes later, you can compare versions. You can ask whether the issue came from the model, the prompt, the data, source, the tool permission, or the policy. Without version context, logs tell you what happened, but not what system produced it. Audit logs are powerful. They are also risky. If you log everything raw, your audit system becomes a new sensitive data store. That means redaction has to happen before storage, mask credentials, remove tokens, hash or replace sensitive identifiers when possible, avoid storing full customer records, avoid storing private message content unless the audit case truly needs it. Separate raw traces from normal audit logs. Use short retention for raw traces. Use stronger permissions for sensitive traces. Use structured fields for routine audit events. The goal is not to hide useful evidence. The goal is to keep enough evidence without creating a second leak surface. A good audit log helps you investigate safely. It should not make every incident response harder because the logs themselves are full of secrets. Once you log events, you need rules for the logs. Who can read them? Who can export them? How long are they retained? Which fields are searchable? Which fields are masked? Which workflows require longer retention? Which workflows require shorter retention? Can logs be deleted? Can logs be tampered with? Can admins view raw traces? Can a user request an audit export? These questions matter because audit logs are evidence. If anyone can edit them, they are weaker evidence. If everyone can read them, they become a privacy risk. If they are kept forever, they become a data hoard. If they are deleted too quickly, you lose your investigation trail. So define the policy before production. Retention is part of the operating model. Access control is part of the operating model. Export rules are part of the operating model. Let us make this concrete. Imagine a vulnerability triage agent. A scanner finding arrives. The agent checks asset criticality. It retrieves policy context. It drafts a ticket update, recommends priority, and it asks for approval before changing anything. The audit trail might look like this. Request received from scanner webhook. Workflow selected vulnerability triage. Finding ID stored as redacted reference. Asset criticality lookup completed. And policy source retrieved. Recommendation generated. Severity change required approval. Human reviewer edited the draft. Ticket update posted. External notification blocked. Agent version recorded. Policy version recorded. Sensitive host details redacted. That gives you a useful timeline. If someone asks why the agent recommended urgent remediation, you can answer. If someone asks who approved the ticket update, you can answer. If someone asks where the sensitive details were exposed, you can answer. That is the difference between an agent that merely acts and an agent you can operate. Here is the checklist I would use for production AI agent audit logs. 1. Log the triggering user, role, or automation source. 2. Log the event type and timestamp. 3. Log the workflow, environment, and target object. 4. Log tool calls and safe result summaries. 5. Log approvals, edits, rejects, and overrides. 6. Log policy, checks, and blocked actions. 7. Log agent, prompt model tool, policy, and data versions. 8. Redact sensitive data before storage. 9. Separate raw traces from normal audit logs. 10. Define retention, access, and export rules. The big idea is simple. You do not need to store everything forever in Delta, but you do need enough structured evidence to reconstruct what happened. If an AI agent is going to operate in real workflows, audit logs are not optional. They are how you debug, prove control, improve trust, and keep the system accountable. If you want more practical AI agents for cybersecurity and automation, subscribe, and I will see you in the next one.